Hello everyone. In this video, I will be explaining question 1, which focuses on the joint probability distribution of two discrete random variables, x and y. The first question is divided into four main parts. First, we determine the value of a constant and construct the joint probability table. Second, we find the marginal distributions of x and y. Then, we check whether the two variables are independent. Finally, we can calculate a conditional probability. So, for part A, finding the constant and joint distribution. So, we are given a joint probability mass function defined as fxy equals to cx plus y for specific values of x and y and 0 elsewhere. Because this is a valid probability distribution, the sum of all possible probabilities must equal to 1. So we add up cx plus y for every element combination of x and y. After substituting the values, the total inside the brackets is 27. This allows us to solve for the constant giving c equals to 1 over 27. Using this value, we then fill in the joint probability table by calculating x plus y over 27 for each pair of x and y. That's it for part A. So we are moving to the part B. We need to determine the marginal distributions. To find the marginal distribution of x, we add the probabilities across each row of the table. Doing this gives px equals to 0, we get 2 over 9. If px equals to 1, we will get 1 over 3. And px equals to 2, we will get 4 over 9. Similarly, the marginal distribution of y is found by summing down each column. So, we use py equals to 1, we get 1 over 9. Py equals to 2, we get 1 over 3. And py equals to 3, we get 4 over 9. So, part C. To check whether x and y are independent, we compare the joint probability with the product of the marginal probabilities. For example, when x equals to 0 and y equals to 1, the joint probability is 1 over 27. However, the product of the marginal probabilities is 2 over 9 times 1 over 9, we get 4 over 81. Since these two values are not equal, we can conclude that x and y are not independent. And last part, we need to calculate the conditional probability for py less than 3, x equals to 2. So, y equals to 3, y less than 3 means y equals to 1 or y equals to 2. We add the joint probabilities for these cases and divide by the probability that x equals to 2. After simplifying, the final answer is 7 over 12. That's it.
Hello, my name is Akif Faris I'm for CS1123B, and I want to explain about my part is question 2. For the question 2A, finding the value of k. Okay, since fxy is a joint probability density function, the total probability over its entire range must be equal to 1. Therefore, the joint density function is integrated of the region 0 until 1 by equating the resulting integral to 1 and solving the equation obtained. The value of k is found to be k equal to 2. Okay, for the question B, the marginal density function of x is obtained by integrating the joint density function with respect to y over its range. Similarly, the marginal density function of y is obtained by integrating the joint density function with respect to x over its range. This integration yield for the fx 2x squared plus 2 over 3x, and for the fy equal 1 over 3 plus y over 6. Okay, for the question C, to determine whether x and y are independent, the function of their marginal density functions is compared with the given joint density function, since fx and fy is not equal to fxy, and y are therefore not independent. Okay, for the question D, the mean of P is obtained using the linearity property of expectation. The expected value of x and y are first determined from their marginal density functions. So substituting this value into the expression for EP gives EP equal to 6EX minus 3EY plus 4, which evaluates to EP equal to 5. To find the variance of P, the variances of x and y as well as the covariance between x and y are required. These are calculated using standard definitions of variance and covariance. The variance of a linear combination of random variables is then applied. Variant P equal to 36 variant x plus 9 variant y minus 36 covariant xy. Substituting the respective value yields, so we get it variance P equal to 71 over 15. Thank you.